This is Process of Science Module 2, and what we're going to be doing in this module is we're going to be looking at some different statistical analyses that we may use occasionally throughout our course in order to better interpret and analyze the data that we've collected. So to begin, if you remember, I had the topic, or I was looking at whether or not caffeine would affect dog heart rate. And so my hypothesis was that dogs that consume caffeine will have a higher average heart rate than dogs that do not consume any caffeine. So let's take a look at the results. Now, I did not actually test this, so don't call PETA on me, but here's some hypothetical data. And so I have dogs that are numbered. I took their control heart rate, so their heart rate resting without any caffeine. Then let's say I gave them 50 milligrams of caffeine and waited 5 minutes, and then I took their heart rate again. And I did actually 3 separate experimental trials, so I have a 50 milligram caffeine, 100 milligram caffeine, and 150 milligram caffeine experimental trials. So what do you think? Well, it's kind of hard to tell. If you look at this dog right here, their regular heart rate was 87 beats per minute, and after 100 milligrams of caffeine, it jumped up to 99. 50 milligram caffeine dog right here jumped from 78 to 80. But that dog's caffeine heart rate is less than this dog's normal heart rate. We have the same thing over here, where this dog has a caffeine heart rate of 86, but this dog's resting heart rate is 87 without caffeine. So it's not always so easy to interpret what's going on with our data. And so we use some different statistical analyses and we make some graphs and things to help us better figure things out. And so if we look at your formula sheet that you are given, one of the statistics that you may need to calculate is something called the mean. And this is what they say to use to calculate the mean, and that's just really confusing. X with a bar over it means mean. And then you've got N is the sample size. This little Greek symbol here means sum. Really, all we're doing is the average. So just add up all your data points, divide by the sample size or how many data points you had, and calculate your mean. So if we go back to my hypothetical data, I have the control heart rate for these 5 dogs right here, and I want to calculate the mean. So I'm going to put 95 plus 88, plus 89, plus 78, plus 88 all into my calculator, and I'm going to end up with 438. But then I have to divide by my sample size. So I had 1, 2, 3, 4, 5 data points, 5 different dogs that I tested. So I need to take that 438 divided by 5, and what I end up with as my mean is 87.6 beats per minute is the average for my control heart rate here. So I'm going to do actually some cheating at this point, and I'm going to use my, spreadsheet capacities to calculate the mean or the average for all of these other trial groups. Okay, so there are my means, my averages for my different experimental results, and I'm going to put these into a bar graph so that I can better visualize the differences. So what do you think of those? Well, I may or may not have just fooled you, because upon first impression, you would see that there doesn't look like much of a difference between the 50 milligram and the control in the first experimental trial, and it looks like there's a much bigger difference here between the 100 and the control. But if you look closer, you can see that I actually changed the scaling on my graph. Up here, I go from 0 to 200, and over here, I start at 40 and I go up to 110. So I have actually kind of zoomed in on this graph to emphasize the differences in my bars. And you'll see this sometimes on commercials where they will have really weird scaling on their y-axis, or maybe they won't even put a y-axis on, or they don't give you time to look at the y-axis. They just want to show you that there's a difference. And so we use different statistical analyses then to try and better represent our data, or maybe to better check the representations of our data. And so one of the other formulas that you'll see on your formula sheet that you may need to interpret is something called the standard deviation. The standard deviation is used to determine the amount by which your values, your data points, are different or deviate from the mean or the average. So in other words, we're trying to figure out what is the spread of our data. And so we call this a normal distribution, this kind of bell curve. And so we have our mean here in the middle, and we measure standard deviations by percentages of how far away you are from the mean. And so we have kind of divvied this up as a normalized standard that one standard deviation away from the mean would be plus or minus 34.1%. And so when we look at the data, 68% of the data would fall within one standard deviation. So 68% of my dog's heartbeats or heart rates would fall within that one standard deviation from the average. Okay, 2 standard deviations then you have to add on to that. That's going to include 95% of my dog's heart rates will fall within 2 standard deviations from the average. And then 3 standard deviations, you're looking at 99%, or almost all of my dog's heart rates would fall within 3 standard deviations. And so standard deviation, again, is how spread out is your data from the mean. And so if we look at standard deviation, you can have different standard deviations, but then also have the same mean. And so if we think about this as test scores, let's say that my class averaged a 50%. So that's my mean right there in the middle. And there was another teacher down the hall, and her class also averaged a 50%. So we both have a mean of 50% on our test scores. But in my class, we had a lot of 40s and 50s and 60% on the test. I didn't have a lot of 70s and 80s, and I didn't have a lot of 20s and 30s. And so I have what you would call a fairly low standard deviation, meaning that there isn't a lot of spread in my data points. In other words, to get to 68% of my class, I don't have to go very far below 50, and I don't have to go very far above 50. But the teacher down the hall, who also had an average of 50%, she had a lot more higher test scores, and she had a lot more lower test scores. And so she had a larger standard deviation. In other words, if she wants to include 68% of her class's averages, she's going to have to go farther above 50 and farther below 50 to include that one standard deviation. If she wants to go to 2 standard deviations, or 95% of her kids' test scores, she would have to go much further below 50 and much further above 50 than I would. And so basically we're talking about if your data really spreads itself away from the mean, you're going to have a higher standard deviation. If your data is really close together around the mean, then you're going to have a lower standard deviation. Now, it's not always so pretty as a perfect bell curve, so this is an example of maybe what a more realistic one would look like. But still in this same instance, we have 2 different data sets. They both have an average or a mean of 100, but the red bell curve is much more closer together, a much less spread. In other words, the data points, 68%, one standard deviation is much smaller than what you'd have to do to include 68% of the data points in the blue bell curve. So standard deviation is something, another formula that's given to you on the AP formula sheet. And we have to look at these symbols and what is actually given to you to understand what we need to do. And so if you look at this sum symbol, sum means add it all up. Where you see X bar, X with a little bar above, we already saw that that means mean or average. XI, that's just a data point. So in this case, it's going to be one dog's heartbeat. And then N is your sample size. So if you tested 1,000 dogs, N is 1,000. If you tested 500 dogs, N is 500. And then S, of course, is the standard deviation, which is what we will be calculating or trying to figure out. And so to give you an example of standard deviation and how we're going to calculate this, the first thing that you have to do is find your mean. Then you're going to take your data point. So let's say a dog had a heartbeat of 50. You would have to take 50 minus whatever the mean was for that group of dogs. Then you're going to have to square the difference between those two. Then you're going to add up all of the squares. So after you take every dog's heartbeat minus the mean and square it, you're going to add all of those numbers up. And then you're going to divide by your sample size, however many dogs you had, minus 1. And then you're going to take the whole thing and take the square root. And that's going to be your standard deviation. And so I'm going to do an example of one of our dog trials for our standard deviation. And so I already have the means here, and I'm going to do it with right here with this control group of dogs. And so we have one dog had a resting heart rate of 95, 88, 89, 78, 88. And so remember, my mean or my average was 87.6. And so to begin with standard deviation, here are my X values. These are my dog's individual data points. My mean, remember, was 87.6. And so what I need to do is take X minus the mean, minus the average. So 95 minus my average, which was 87.6, the difference is 7.4. 88 was this dog's heartbeat, minus the average, which was 87.6, and that was only a difference of 0.4. So I went all the way down and did that, subtracted the mean from each of these dogs' heartbeats for all 5 dogs. The next step that I'm going to have to do is square this difference. And so 7.4 squared is 54.76. 0.4 squared is 0.16. Over here we had a negative number, but anytime you square negatives, it ends up with a positive. So you're going to have all positive numbers over here on this column. Then the next thing that the formula tells us that we have to do is add these all up, the sum of the differences squared. These are my differences squared. And so what I end up with is 149.2. All I did was add all of these numbers right here up. Then the next step is I have to divide by n minus 1. Well, n is my sample size. I tested 5 dogs, so n minus 1 is 4. So I have to take 149.2 divided by 4, and I get 37.3. Very last step, I have to take the square root. So the square root of 37.3 is 6.1. And so when I come back here to this group of dogs right here, after I've calculated the standard deviation, I end up with 6.1. Now, I'm going to do that exact same thing for all of my other dog groups. So it's going to take some time for me to calculate this. Oh, but I can use the masterful spreadsheet to actually calculate standard deviations for me. So never mind my cheating here. We want statistical. Standard deviation. Boom. There we are. So that is the standard deviations. What does that mean? Well, let's go back to the one that I just calculated. I had a mean of 87.6, but one standard deviation is 6.1. So let's come back to my bell curve. That means right here in my mean is my average dog heart rate of 87.6. If I want to show one standard deviation, so 68% of my dog's heart rates are going to be either within 6.1 heartbeats below 87.6 and within 6.1 heartbeats above 87.6. If I want to show 2 standard deviations, now I have to add 12.2. So my average was 87.6. I could go 12.2 heartbeats this way, I could go 12.2 heartbeats that way, and that would be 2 standard deviations above or below the average. And that would encompass, remember, about 95% of my data points. So about 95% of my dog's heartbeats are going to fall within 2 standard deviations. In this case, that would be 12.2 beats per minute.